Imagine a distant star burning faintly in the vast expanse of space, 154 light-years away. It's sending out a rhythmic cosmic pulse, a steady beat echoing across the light years. And this pulse, this signal, has caught NASA's attention, piquing the curiosity of scientists around the globe. This isn't a message from aliens, a coded transmission from another civilization, but a natural phenomenon, a cosmic dance playing out on a grand scale. It's the discovery of TOI 1846b, a planet unlike any in our solar system, a world that defies easy categorization. The story began with a faint, repeating dip in a star's light, a subtle flicker in the darkness, a sign that something was orbiting, circling its host star with unwavering regularity, blocking a tiny fraction of its glow, casting a fleeting shadow on the star's radiant face. Our telescopes, ever vigilant, detected this pattern, this telltale sign of a world beyond our own, revealing a world that challenges our ideas about planet formation, forcing us to rethink what we know about the cosmos. The signal isn't a radio wave, a burst of energy crackling through the void, but the planet's very presence, its sheer existence in such an unexpected location, its gravity and orbit, the way it tugs at its star and carves its path through space, creating a powerful, puzzling signature, a cosmic riddle etched in starlight. TOI 1846b's density, close orbit, and mysterious nature have scientists racing to uncover its secrets, eager to unravel the mysteries of this distant world. Why is it so dense? What strange materials compose this enigmatic world? How did it get so close to its star? What cosmic forces shaped its improbable journey? Could it possibly hold water? Could this alien world harbor the building blocks of life? Every new planet is a chapter in the cosmic storybook, a page filled with wonder and the promise of discovery. And TOI 1846b is one of the most exciting yet, a truly remarkable find in the vast ocean of space. It's a super-Earth, a type of planet missing from our solar system, a class of world we can only dream of visiting. Located in a fascinating region of space, a neighborhood teeming with other exotic worlds. As we learn more about this world, as we piece together the clues it offers, we learn more about our galaxy, its hidden secrets and untold possibilities, and our place within it, our humble position in the grand cosmic tapestry. Let's dive in and explore the signals from this remarkable new world, and embark on a journey of discovery together. In the vast expanse of the cosmos, beyond our familiar solar system, lie worlds that challenge our very understanding of planetary formation. What is a super-Earth? It's a planet that occupies a fascinating middle ground, a celestial body bigger than our own Earth, but smaller than the ice giant Neptune. These intriguing planets can range up to twice Earth's size and potentially 10 times its mass, showcasing a diverse range of densities and compositions. Super-Earths can be rocky, like our own terrestrial planets, or they might be water worlds, completely covered in vast, deep oceans. And remarkably, they're among the most common types of planets populating our Milky Way galaxy, far outnumbering gas giants and even smaller rocky worlds. It's a cosmic irony that our own solar system, with its familiar arrangement of planets, has none of these super-Earths. Their stronger gravitational pull, compared to Earth, could enable them to hold on to thick, dense atmospheres for extended periods, which is crucial for regulating surface temperature, distributing heat evenly, and protecting against harmful space radiation. Furthermore, more internal heat, generated from their formation and composition, could drive significant volcanic and tectonic activity, potentially creating stable and long-lasting habitable environments where liquid water could exist on the surface. One such fascinating example is TOI 1846b, a high-density super-Earth discovered orbiting a distant star. This planet is particularly intriguing because it appears to be packing a massive iron core at its center. In fact, this iron core is much larger proportionally than the core found within our own Earth. This unusual characteristic challenges our current models of planet formation and evolution. It begs the question, how does a planet end up with such a disproportionately huge core and a relatively thin outer layer of mantle and crust? Super-Earths like TOI 1846b force us to fundamentally rethink what's possible in the diverse realm of planetary systems. In contrast to the rich variety found throughout the galaxy, our solar system makes a rather abrupt jump from small rocky worlds to giant gas planets. But the universe, in its infinite creativity, is teeming with these fascinating in-between worlds, bridging the gap between the familiar and the unknown. By studying these enigmatic super-Earths, we can significantly expand our understanding of the fundamental processes that govern how planets form, evolve, and potentially become habitable. Each newly discovered super-Earth serves as another valuable clue in the ongoing puzzle of planetary origins and the conditions necessary for life to arise. TOI 1846b, with its peculiar composition and density, represents a key piece of this intricate puzzle. By studying these worlds, we are ultimately helping us build a more complete and nuanced picture of the cosmos and our place within it. How did we spot a planet 154 light-years away? With NASA's TESS, the Transiting Exoplanet Survey satellite. TESS scans thousands of stars, searching for tiny regular dips in brightness, transit events, caused by planets passing in front of their stars. Imagine a gnat flying across a searchlight. You don't see the gnat, but you notice the brief dimming. TESS is sensitive enough to catch these minuscule changes, revealing planets by their shadows. For TOI 1846b, TESS detected dips every 1.6 days, a strong clue of a planet's presence. Once flagged, scientists use other telescopes to confirm the find and rule out false positives. The amount of light blocked tells us the planet's size. The timing reveals its orbit. Even the color of starlight passing through a planet's atmosphere can hint at its composition. TESS has revolutionized our understanding of exoplanets, giving us incredible targets like TOI 1846b. It's the first step in unraveling the mysteries of distant worlds. TOI 1846b orbits a red dwarf, the most common star type in the Milky Way. Red dwarfs are smaller, cooler, and dimmer than our Sun, burning fuel slowly and living for trillions of years. Their small size makes it easier to spot orbiting planets, since a planet blocks a larger fraction of their light. TOI 1846, the host star, is about half the Sun's size and much cooler, so its planets must orbit close to stay warm. TOI 1846b completes a year in just 1.6 Earth days, a tight, dynamic orbit. The planet's gravity tugs on the star, causing a slight wobble, another clue for astronomers. Red dwarfs offer long-term stability, but can unleash powerful flares that threaten planetary atmospheres. This delicate balance shapes the potential for habitability around these stars. Understanding this relationship is crucial as we search for life beyond our solar system. Let's zoom in on TOI 1846b, a fascinating exoplanet that's capturing the attention of astronomers worldwide. We're about to embark on a journey to understand its unique characteristics and what makes it so different from the planets in our own solar system. It's about 1.8 times Earth's radius, making it significantly larger than our home planet. This size difference has profound implications for its composition and potential habitability. This places it firmly in the super-Earth category, a class of planets that are larger than Earth but smaller than Neptune. Super-Earths are particularly interesting to scientists because they don't exist in our solar system. But its mass, 8.5 times that of Earth, reveals a surprising characteristic about this distant world. This high mass, combined with its radius, makes it unusually dense, far denser than what we typically observe in planets of similar size. This suggests a massive iron core, potentially taking up a significant portion of the planet's interior. This core is likely surrounded by a thinner rocky mantle than expected, a stark contrast to the proportions we see in Earth and other rocky planets in our solar system. This unusual composition is unlike what current planetary formation theories predict for a planet this size, challenging our understanding of how planets are born and evolve. Adding to its list of unusual features, its orbit is extreme, just 1.6 days. This incredibly short orbital period places it very close to its star, much closer than Mercury is to our Sun. Consequently, it is subjected to intense heat and radiation from its host star. The estimated surface temperature is around 800 degrees Celsius, 1,500 degrees Fahrenheit. That's hot enough to melt many metals, creating a truly hellish environment. These extreme temperatures make surface life as we know it impossible. However, this also creates a unique laboratory for studying extreme planetary conditions and testing our understanding of planetary physics. Despite the scorching heat, there's still a chance TOI 1846b harbors water in some form. This water wouldn't exist on the surface, but potentially as ice deep within the planet's interior, shielded from the extreme heat. Alternatively, it could exist as high-pressure steam in its atmosphere, creating a dense and potentially observable cloud layer. Its high density could also mean it formed farther out in its planetary system, where water ice was more abundant. In this scenario, it would have captured water during its formation before migrating inward to its current close orbit. The idea of a hot, steamy super-Earth with a hidden reservoir of water is one of the most intriguing possibilities and a prime target for future study with advanced telescopes. Powerful telescopes like the James Webb Space Telescope may soon reveal if this world truly has a watery past, unlocking secrets about its formation and evolution. TOI 1846b is a scientific puzzle waiting to be solved, offering a glimpse into the diverse and often surprising nature of planets beyond our solar system. TOI 1846b sits in the mysterious radius gap, a size range where few planets are found. Astronomers noticed a dip in the number of planets between 1.5 and 2 Earth radii, likely due to atmospheric loss. Planets in this range can't hold on to thick atmospheres when close to their stars. Intense radiation strips them away, a process called photoevaporation. This creates two groups: dense, rocky super-Earths and puffy mini-Neptunes. TOI 1846b, at 1.8 Earth radii, is rare, a transitional fossil in planetary evolution. Its high density suggests it's lost its original atmosphere, leaving a rocky core and mantle. Studying it helps test theories about how planets evolve and lose their atmospheres. Each discovery like this turns a statistical oddity into a physical process we can understand. TOI 1846b is a key to unlocking the secrets of planetary evolution. Orbiting so close to its star, TOI 1846b is almost certainly tidally locked. One side always faces the star, the other is in perpetual night. This creates extreme conditions, a scorching day side and a frozen night side. The terminator zone between them could have more moderate temperatures. If the planet has an atmosphere, fierce winds might circulate heat, creating a steamy, high-pressure environment. Water could exist as vapor or in exotic states under immense pressure, unlike anything in our solar system. Studying such a world helps us model climates and chemistry on extreme exoplanets. TOI 1846b is a natural laboratory for exploring the boundaries of planetary science. Discovering TOI 1846b is a global effort. Space telescopes like TESS find candidates, but ground-based telescopes confirm and characterize them. Instruments like Maroon X at Gemini North measure the star's wobble, revealing the planet's mass and density. This teamwork is essential. TESS spots the planet, ground telescopes weigh it, and together they reveal its nature. The next step, the James Webb Space Telescope, which can analyze starlight passing through the planet's atmosphere during transits. JWST could detect water vapor, methane, or carbon dioxide, testing the steamy world hypothesis. This collaboration brings us closer to understanding super-Earths like TOI 1846b. It's a symphony of science unlocking the secrets of distant worlds. The discovery of TOI 1846b is a milestone, but just one step in our cosmic journey. There may be more planets in this system waiting to be found, each one a clue to how planetary systems form. These discoveries help refine our theories and build a catalog of worlds for future study. We're moving from counting planets to understanding their atmospheres, compositions, and potential for life. Every new world expands our perspective and inspires the next generation of explorers. The signal from TOI 1846b reminds